Okay, so today's topic is center of mass of a system. So how to calculate center of mass of any system. Now, there are few things that you need to remember, like uh, how to identify the center of mass when any body is given, and if the center of mass is not given, then how to use mathematics to find center of mass. So first, let us go to identification. Suppose we have, like, there's a disk. So this is center of mass. This is a disk, but there's a hole in between. So this is center of mass. This is a square. So where the diagonals will intersect, this is the center of mass. For a triangle, the centroid will be center of mass. The center of mass in simple terms is said to be a point where an object balances itself. Balances means if you will hold any triangle from its center of mass, then it will not rotate. So it's like this. So all the mass is concentrated at center of mass. It is just assumed that all the mass is concentrated at center of mass. Now let us calculate center of mass of complex systems. Suppose that I'll give you that we have mass m1 whose position coordinate is r1, and we have another mass m2 whose position coordinate is r2. So the position coordinate of center of mass will be m1 r1 plus m2 r2 upon m1 plus m2. So this is the position coordinate of center of mass. Now let us take an example of this. Suppose I'll say that 2 kilogram mass is located at 2 comma 1 and 5 kilogram mass is located at minus 1 comma 2. So where will be the center of mass? So the position of center of mass will be given by the first mass is 2 and the position vector is 2 I cap plus j cap because 2 comma 1. Second mass is 5 and the position coordinate will be minus I cap plus 2 j cap because minus 1 comma 2. And total mass will be 2 plus 5 7. So this is how you have to calculate center of mass when the masses are point masses. So m1 is at a point, m2 is situated at a point. Suppose we have 3 mass, then you can add m3 r3 in numerator and plus m2 in denominator. We have 4 mass, then you can just expand this formula. Okay, so this is how you have to calculate center of mass when point objects are there. And suppose we have extended objects, like suppose I give you a question that there are two rods positioned like this. The mass of first rod is m, length is L. Mass of second rod is m, length is L. And suppose this is origin 0, comma 0. So if I'll ask you where will be the center of mass located? So we have first mass m, whose center of mass will be here. Because center of mass of any uniform rod will be at the center. And if you'll see, if you look closely, then the center of mass will be at this point. So at this point, if you'll see, we have to only come in upward direction. How much? L by 2. We don't have to go in x direction. So it will be 0, comma L by 2. Because to come at this point, we have to only move in y direction. We don't have to move in x direction. So x coordinate will be 0, y coordinate will be L by 2. So for m, the position coordinate will be 0 I cap plus L by 2 j cap. And for second mass, for this mass, the position of center will be here. So to reach here from origin, I have to only come in x direction. I don't have to go in y direction. So the coordinate of this point will be L by 2 comma 0. So it will be L by 2 I cap plus 0 j cap. Now you have to just use this formula. That is RCOM is basically M1 R1 plus M2 R2 upon M1 plus M2. So if we put the value of M, and the coordinate will be 0 I cap plus L by 2 j cap plus M, and its coordinate will be L by 2 I cap plus 0 j cap divided by total mass will be 2M. So if you open it, you will get the center of mass of this extended body. So for point mass, you have to use that method. And for extended of bodies, you have to use this method. Suppose I'll ask you, what will be the center of mass of this system? Suppose I have one road like this, another road like this, and another road like this. And suppose this is the origin. So the center of this road will be here and the coordinate will be 0, comma L by 2. Center of this road will be here. The coordinate will be L by 2 comma 0. But if you'll see, the center of this road will be here. So to reach at this point, I have to first travel in X direction. How much I have to travel? L. Then I have to travel L by 2 in Y direction. So the coordinate will be L comma L by 2. So this is how you have to first find the center of individual object. Then you have to put in our formula, that is M1R1 plus M2R2 plus M3R3 upon M1 plus M2 plus M3. Okay, now suppose I'll take one more example. Suppose that I'll give you that this is an area. Suppose this is 2 meter, this is 6 meter, this is 2 meter, this is 2 meter, and this is your origin. And suppose I ask you where will be the center of mass of this object. So if you'll see from geometry, this will be 8 meter and this is 2. So if I'll let's make it 8. So this will be 8. So this will be 8 meter and this will be 2 meter. Okay, now where will be the center of mass of this body, this plane body? So in this case, you can use this formula. When plate is given, then you can use this formula. A1R1 plus A2R2 plus A3R3 divided by A1 plus A2 plus A3. Now, in this question, we have two areas. This is area number 1. So you can see the A1 will be equal to 8 to the 16. And this is your area 2. On this side of dotted line, it will be also 8 to the 16. But the center of this area will be here. Now what will be the coordinate of this center? So this is center. So first I have to calculate, first I have to come 1 meter in X direction, because this is 2 and center will be in half. And this is 8. So I'll have to go 4 meter in upward direction. So for this A1, the center coordinate will be 1, 4. And for this A2, the center will be here. So to reach here, now how I'll reach here? Dekho. First you have to come up to this point. So this is it. So this will be 4 and this is 2. So in X direction, I have to travel 4 plus 2, 6. But this is 2. So in Y direction, I have to travel 1. So it is 6, 1. So we have A1 16 and this position vector is 1, 4. So R1 will be I cap plus 4j cap. A2 is 16 and the coordinate will be 6 I cap plus j cap. So just you have to just put this value. So 16 I cap plus 4j cap plus 16 6 I cap plus j cap divided by 16 plus 16. So if you solve this, you will get the coordinate of center of mass.